Hello everybody, so for this video we are going to focus on the assignment that's on Canvas that's called Worksheet Quadrilaterals Coordinates 2 and 3. Your assignments will be these two worksheets at the bottom and you will need to input your answers on Canvas. For our notes, we are going to look at this first link that says Worksheet Quadrilaterals Coordinates. I'm going to click there and it's going to ask me to open it in a Word document. I'm going to click on Enable Editing. I'm going to zoom in. Okay. And if I click on Review and do Start Inking, I will be able to annotate over all of this document. And if you click on the right hand side, you will be able to move the document up and down, but the markings will stay with the document. They won't move around. So I'm going to start and I'm going to use red. You can choose any color you want and you can also choose different colors here. So the first thing it says is to plot the points. So I'm going to go ahead and plot the points on the graph and I'm going to plot -3, +2. A 0, 4, 1, 2, 3, 4. Right now I'm using a stylus, so if you have a stylus you can use your stylus or you can use your hand or your finger to annotate over the work. 1, 2, 3, 4, and down 2, and then 1, 1, 2, 3, 4. Okay. Right, I'm going to connect my points. Sorry about my crooked lines. Okay, so we need to determine what kind of quadrilateral is being graphed, but we need to be able to show it using math and being able to explain why that quadrilateral is what we're claiming it is. So in order to do that, the first thing that it says is to find the lengths of the sides. So if you look at this quadrilateral, all the line segments are diagonal. So in order to find the lengths of diagonal line segments, we need to use Pythagorean theorem because we are going to connect A and B and we are going to form right angles. So I'm going to connect the points A to B. And notice how this is a right angle, so that makes A and B be your hypotenuse. So I'm going to find the lengths of the legs. So in this case, this measures 3 and this is 2. So in order to find the hypotenuse, I can use Pythagorean theorem since I know the two legs. So I'm going to use a squared plus b squared equals c squared. And I'm getting 2 squared plus 3 squared equals c squared. So that's 4 plus 9. I'm going to scroll down a little bit. 4 plus 9 is 13. Take the square root of both sides. So remember that when we take the square root, we have two answers, a positive and a negative, but in this case it does not make sense to have a negative for an answer because we are looking at side lengths and side lengths cannot be negative. So this is going to stay as square root of 13. But you know that the square root of 13 is also a number and you can get the decimal. I always like to have both answers just so you know that square root of 13 is exact and then the other one is your decimal, which is not an exact number. We are approximating. Okay, so we found the distance of AB. So line segment AB measures square root of 13, which is the same thing as 3.61. I do like decimals though because it gives you a better idea of what kind of numbers we're looking at. You obviously can't have like a huge number because in this case it would not make sense. So now I'm going to find the other side lengths And I'm going to find CD just because it looks like it measures the same as AB, but I don't know that yet. So I'm going to draw another right triangle so that I can see if that's going to be the same distance. And this leg measures 3 and that measures 2. So it is the same triangle, and so the hypotenuse should be the same. So CD, line segment CD, measures the same thing as AB, but I'm going to write it down. And I'm going to find the side lengths of BC and AD. So I'm going to choose a different color. I'm going to connect B to C. 1, 2, 3, 4. The leg is 4. 1, 2, 3, 4, 5, 6. The other leg is 6. So I'm doing Pythagorean theorem again since I'm finding the hypotenuse. C is the letter that I don't know. So it is 4 squared plus 6 squared equals C squared. So that's 16 plus 36 equals C squared. And that is 52 equals C squared. Scroll down. So the square root of 52 simplifies to 2 square root of 13. How are they getting 2 square root of 13? Well, 4 times 13 is 52 and the square root of 4 is 2. And it has to be positive because it is a side measure. And so I know that I found BC. So BC is 2 square root of 13, which is also a decimal. So that's 7.21, and it does make sense that this is bigger than the side lengths because they are bigger in my graph. So I'm going to find the last one. So AD, form another right triangle so that I can find the hypotenuse. 1, 2, 3, 4, 5, 6, and that's 4. 1, 2, 3, 4. So I know that AD measures the same as BC. Okay, so what do we know from that? We know that not all the sides measure the same, so we obviously cannot have a rhombus and we cannot have a square. So this is where the properties of our quadrilaterals come in handy. So based on what we know, I know that AB and CD are opposite sides and BC and AD are opposite sides. So what does that tell us from this information? I'm able to say that opposite sides are congruent since opposite sides measure the same. Okay, so now I know that of all the quadrilaterals, the only shapes where opposite sides are congruent but where not all of the sides are congruent would be either a parallelogram or a rectangle. So I am in between those two shapes. Well, what sets them apart? Several things set them apart. One of the biggest things are the right angles and a rectangle. So we need to find the slopes of the sides and see what happens. So I'm going to choose a different color right now. And I'm going to find the slopes of the sides. So I'm going to start with BC. So the slope, so I'm using M for slope. Okay, sometimes my stylus messes up. Okay, so the slope of line segment BC is rise over run. So remember, if you are going up, it's positive. If you are going down, it's negative. If you are going to the right, it's positive. And if you are going to the left, it's negative. Okay, so the slope of BC, if I'm going from B to C, that's right, so I'm going down 6 first and then right 4. So down 6, that would be negative 6 over 4, which simplifies to negative 3 over 2. And I'm going to go in order, so CD. So you can go down, which would be negative 2, and left, which would be negative 3. So negative 2 divided by negative 3 is positive 2 over 3. Or you can go from D to C. So go up 2, that's positive. Right 3, that's positive. So we get the same thing, which is 2/3. We get the same thing if I had went from CD or from D to C. So the next one is DA, and to go from A to D, I'm going to go down 6 and right 4. So that's the same thing as this one. So I know AD is also negative 3 over 2. And to go from A to B, I'm going up 2, right 3. So AB is up 2, right 3. So a few things that I notice. I notice that these two line segments are the same. If the slopes are the same, what does that tell us about the line segments? That the line segments are parallel. Same thing with BC and AD. So if we notice the position of BC and AD, BC and AD are opposite line segments. So opposite sides are parallel because the slopes are the same. Same thing with AB and CD. They're opposite sides, the slopes are the same. The opposite sides are parallel because the slopes are the same. So from that information, I can put that opposite sides are parallel. And remember, we know they're parallel because the slopes of the opposite sides are the same. Okay, and the last thing we can conclude is that these, what do you notice about these slopes right here? They're opposite reciprocals. One's positive, one's negative, and then they're flipped. So which side lengths are those? BC and CD. So let's see. BC and CD. So that means if the slopes are opposite reciprocals, that means that the lines are perpendicular. So what happens when two lines are perpendicular? They're forming 90-degree angles. And that should be the same for the rest. Let's see. I want to see if CD and AD, since they're adjacent sides, I want to see if these sides have slopes that are opposite reciprocals. And that's AD and CD. AD and CD. Notice how these are opposite reciprocals. So yes, they'll form 90-degree angles. And DA and BC, they're adjacent sides. And DA and BA, DA and BA, they're here. They are also opposite reciprocals. So yes, they're going to form 90-degree angles. And the same is true for BA and BC. So we know that although these two properties are the same for both a parallelogram and a rectangle, the last property that sets it apart is that adjacent sides are perpendicular, telling us that it's a rectangle. Thank you for watching. Let me know if you have any questions.